Good morning, students. Let's start today's class. Okay, in today's class, we are going to study about scrambling technique, which is the last technique used for digital signal encoding process. Okay, in previous classes, we have already studied about three uh, techniques, which is non-zero, non-return to zero. One is non-return to zero techniques. Second one is biphase techniques. Third one is bipolar techniques, and fourth one is we are going to study today. Okay, which is scrambling techniques. Although the biphase technique have achieved widespread use in local area network, but it cannot be used in long distance application by because of because for biphase the channel bandwidth needed is very high, that is double of the natural bandwidth needed for data transmission. That means previously we have studied that biphase technique is used widely in LAN or wide area network. That means for short distance communication, but for long distance communication it cannot be used because the in biphase technique the required amount or the requirement of bandwidth of the channel is very high. That means double of the natural bandwidth required. That means we cannot use it as the bandwidth is very high of or requirement of bandwidth is very high for the channel due to the cost effective. Okay, due to the costly channel. Okay, but in next the next the next is bipolar MI, alternative mark inversion band technique. Okay, in this technique the bandwidth is not that high. Okay, but if any instant large number of zeros are going to transmit, then there is a synchronization problem. Okay, in what happened in bipolar AMI, that in bipolar AMI you have recalled that what in bipolar AMI we uh, for a binary zero we encoded that as a zero voltage which is constant. Okay, and for binary one the voltage level is alternate between positive voltage and the negative voltage. So if a consecutive number of zeros will be transmitted or we want to transmit a consecutive number of zeros, then the synchronization process is uh, or the synchronization process is mismatched in between transmitter and the receiver. Okay, since the consecutive zero or the non uh, non identify of the levels of clock pulse. Okay, so for overcome these problems we modified bipolar AMI rules and create a scheme called scrambling. Okay, in scrambling what happened, the sequence that would result in a constant voltage level on the line are replaced by filling sequence that will provide sufficient transition for receiver's clock at the maintaining of synchronization. That means in scrambling what happened, the consecutive zero level or the consecutive zero voltage level is replaced by such sequence. Okay, such sequence uh, provide that will provide sufficient transition for receiver clock. Okay, or to recognize the receiver clock in the to recognize the clock pulse in the receiver end to maintain the synchronization. And the replaced or replacing sequence or the sequence which is used for replacing purpose in the sender side should known to the receiver end, okay, so that he can revoke that sequence and get the original information, okay. There are two type of scrambling techniques. One is bipolar with 8-0 substitution, which is B8ZS, and second one is high density bipolar 3-0, which is HDB3. Okay. Now let us discuss about bipolar with 8 zeros substitution. Okay. It is commonly used in North America. Okay. It is commonly used in North America. This coding scheme is based on bipolar AMI. Okay, this coding scheme is based on bipolar AMI. Okay, and the rule for the BTS, the B8ZS is if an octa or 8, if an octa or 8 of all zeros, that means 8 number of zeros, consecutive zeros occurs, and the last voltage pulse preceding the octas was positive, okay, then these 8 zeros of octa are encoded as 0 0 0 plus minus 0 minus plus. This plus minus is positive voltage level and minus is negative voltage level. 0 is 0 voltage level. Okay, that means when the 8 0 occurs consecutively, then and that 8 0 is or the past uh, pulses, the past pulses or the last pulses of that 8 0 is positive. Okay, that means after positive there are 8 zeros. Okay, then the 8 zeros is replaced by this sequence, and we can use as in different books that sequence also denoted as this 0 0 0 V B 0 B V. V means violation. V means we'll see later what is V, what is B. Okay, and now discuss about the second rule. Okay, in second rule, if that 8 number of zeros occurs and the last of that 8 number of zeros, okay, is negative. In first rule, the last pulse is positive. Okay, the last pulse is positive, but in second rule the last pulse is negative. Then the 8 0 octal is encoded as 0 0 0 minus plus 0 plus minus. See the difference. Okay, if the positive, if the last clock is positive, then 0, then start with plus, then minus, then plus. 0 are common for both of the cases. Okay, but in the case when the last bit is negative, start with the negative, then positive, then 0, then positive, then negative. Remember that. Okay, and now see what is B and what is V. Okay, V means violation. V means violation. Okay, means the same polarity at the polarity of previous non-zero. That means when the 8 consecutive happened, okay, that 8 previously, that 8 consecutive or the previous non-zero level, the previous or non-zero level polarity is as V. Okay, and the B is, and B means means the opposite polarity to the polarity of previous non-zero. We'll understand what is V and B clearly in the waveform. Okay, now see, in first case, this is first case. Okay, in first case, what is the rule? Rule said, if the last bit or the last clock pulses is positive of 8 consecutive zeros, then it will encoded as 0 0 0 0 0 0 positive negative 0 negative positive. Okay, now let's see what happened. Okay, here the AMI clock pulses. Okay, that is 1 0 1 0 0 0 0 0 0 0 0 1. 8 number of zeros are there, so this 8 number of zeros encoded as this is BSI, and since this 8 number of zeros uh, precedes positive voltage, or the last pulses of that 8 number of zeros is positive. Okay, so this coding or thus encoding rule applied. Okay, so how this encoding rule applies? See, positive carry same positive, and this 0 is this 8 number of zeros is encoded as 0 0 0, then positive, then then negative, then 0, then negative, then positive. Okay, this is the encoder or the encoding process, and this one is also as like as the input signal. Okay, and this, and now let's see what is V and B. Here this is V. Okay, and this is B, and this is B, and this is V. Okay, you see, V, I told you V means the same polarity as the polarity of previous non-zero. This V polarity is positive because the previous non-zero polarity, this is 0, this is 0, this is 0, this is non-zero. Okay, poles. Previous non-zero polarity are what? That polarity followed by the V. Okay, this is positive polarity, so that the V is positive polarity, and the B is the opposite polarity of previous non-zero. The previous non-zero polarity is positive, so that the B is negative polarity. Similarly, here B is negative polarity due to the previous non-zero polarity is positive, and the V is positive polarity because the previous polarity is positive. Okay, you understood? Next, in the second case, what? The if the negative, then the negative poles, then 8 zeros are there. Okay, 8 zeros are there, then it will encoded as 0 0 0 negative positive, sorry, negative positive 0 positive and negative. Okay, this is the rule. Okay, here you see the 80 is precede, or the last pulse of that 80 is negative, so this rule is applied. Okay, negative negative, then 0 0 0 negative positive 0 positive negative. Okay, and here V, see, same thing. V is previous non-zero polarity negative, so V is negative, and B is opposite to the previous non-zero polarity, so previous non-zero polarity is negative, so B is positive. Similarly, B is negative and B is positive. Okay. Now let's see what is high density bipolar 3-0 techniques. Okay, it is commonly used in Europe and Japan. The previous method commonly used in America. Okay, and this method is commonly used in Europe and Japan. Okay, it is also based on the bipolar AMI scheme. Okay, here four consecutive zeros voltage are replaced with sequence this or this. Okay, in previously 8 consecutive zeros. Okay, 8 consecutive zeros is replaced with 2. One is 0 0 0 0 positive negative 0 positive negative, and another one 0 0 0 negative positive 0 positive negative. Okay, here the 4 zeros we consider 4 consecutive 0 and replaced with this or this. Okay, rule are, if the number of 0 pulses after the last subsequent substitution is odd, if the number of non-zero pulses after the last substitution is odd, okay, that means odd number of non-zero pulses are there before the substitution happened, the substitution pattern follow 0 0 0 V. Here V means the same polarity as the previous non-zero polarity. Okay, and if the number of non-zero pulses after the last substitution is even, then the substitution pattern is B00V. B here is the opposite polarity before or opposite polarity previous non-zero pulses. Okay, now see the waveform, you can understood better. Okay, substitution. Okay, see here the what data given, here the data given. Okay, and the by here, since there is 4 consecutive zeros, we use this encoding method. Okay, and before 4 consecutive zeros we should see, or we should consider how many non-zeros are there, non-zero labels are there. Okay, here the 2 non-zeros are there, that means it is even number of non-zero labels. Before that 4 consecutive zeros. Okay, even number of non-zeros are there. So in according to our rule, if if the non-zero labels before the substitution is even, then we use encoding process, that is B that is B00V. Okay, B means opposite polarity before opposite polarity of previous non-zero. Okay, so this is B. Okay, which is opposite polarity of before non-zero state. It is negative beforely, and so that the B is positive, and 0 0 and V means the same polarity before non-zero. Okay, same polarity before non-zero level, that is positive, so this one also positive. Okay, and now let's see another 4 consecutive zeros are there, and according to our method scheme rule, we should consider the before how many labels, how many pulses, non-zero pulses are there after the last substitution. The last substitution end here, okay. The last substitution end here, okay. After that, one non-zero pulses are there, so the number of non-zero pulses is odd, okay, here odd. So here we use the encoder, which is 0 0 0 V, okay, 0 0 0 and V or same as the polarity in of previous pulses, okay, for previous non-zero pulses. This is negative, so the B is negative, okay. And this and after after that, one another four consecutive zeros are there, okay, but these consecutive zeros didn't have any number of non-zeros pulses after the last substitution, okay. This third number of zeros, subsequent zeros, didn't have any non-zero or non-zero pulses, okay, after the last substitution. But we if the non-zero pulses after the last substitution, that means we take that as a even. That means if there is no non-zero pulses after the last substitution and before the subsequent before the um, before the coming substitution or before the going to substitute process, then we consider that as a even, okay. And we use the encoding process for even is B0 0 V, okay. Here you see this is B, this is the previous opposite polarity of previous non-zero. Previous non-zero is this much negative, so this is positive, okay. And 0 0, this is V, okay. This is V, which is same polarity as the previous non-zero polarity. Previous non-zero polarities is previous non-zero polarity is positive, so this is positive, okay. That's all. Thank you.